In episode 16, titled Essential Terms, Plain Language Glossary for Fast Recall and Clear Definitions, the goal is to build a glossary that can be explained clearly without jargon, because clarity is what keeps exam answers and workplace communication consistent. The CompTIA Data Plus DA0-002 exam is full of terms that sound familiar, yet many errors come from using them loosely or mixing them with nearby concepts. A plain language glossary works because it forces each term to connect to a simple meaning and a practical use, which is how the brain recalls ideas under time pressure. This episode keeps definitions short, concrete, and work-focused, with just enough context to make the word usable in a scenario. The point is not to sound academic, but to sound accurate and steady, because that is the style the exam tends to reward. By the end, the glossary becomes something that can be spoken aloud in clean sentences, which is the strongest test of understanding. A dataset is a collection of data that belongs together for a purpose, like a table of sales, a set of log events, or a folder of survey responses. A record is one unit within that dataset, like one sale, one customer, or one log event, and it is usually represented as one row when the data is structured. A field is one named piece of information inside each record, like order date, product category, or error code, and it usually appears as a column in a table. A value is the specific content in a field for a particular record, like the order date for one sale or the status code for one request. These four terms are basic, but they quietly control how questions are interpreted, because many stems describe errors that really come from confusing what a record represents or what a field is supposed to mean. When these words are used precisely, it becomes easier to reason about joins, missing values, and aggregation without drifting. A primary key is a field, or a set of fields, that uniquely identifies each record in a table, meaning no two rows share the same key value. A foreign key is a field in one table that points to a primary key in another table, creating a link that expresses how the records relate. A relationship is the connection between tables built through those keys, such as one customer having many orders or one product appearing in many order lines. These ideas matter because relationships are what make joined queries possible, and poor key choices are one of the biggest sources of wrong totals and missing matches. On the exam, a stem that describes duplicated rows after a join or missing rows in a report is often testing key and relationship thinking rather than complex math. Clear key language also supports governance, because a key often becomes the unit used to trace data back to a person, system, or event. A schema is the set of rules that defines how data is organized, including what tables exist, what fields they contain, what types those fields have, and what relationships connect tables. A table is a structured collection of records arranged in rows and columns, typically used to store entities or events in a consistent format. A view is a saved definition of a query that presents data as if it were a table, often used to simplify access or standardize logic without copying the underlying data. An index is a structure that helps a database find rows faster based on a field, improving query performance for common filters and sorts. These terms often appear together in real work because a schema is implemented through tables, views help users access tables safely and consistently, and indexes help the system respond quickly at scale. In exam stems, tables and schemas usually signal structured data work. Views often signal standardization and access control patterns, and indexes often signal performance trade-offs. The key is to connect each term to what it changes, meaning structure, presentation, or speed. A pipeline is the sequence of steps that moves data from a source to a usable destination, usually including collection, cleaning, and delivery into a system where it can be queried or reported. Ingestion is the act of bringing data in from a source, such as loading a file, pulling from an API, or receiving a stream of events. Transformation is the act of changing data so it becomes consistent and usable, such as fixing types, normalizing formats, removing duplicates, or mapping codes to labels. Load is the act of writing the ingested and transformed data into a destination, such as a database, warehouse, or lake, so other processes can use it. These terms are easy to say and easy to misuse, so the best habit is to tie each one to a plain action, meaning bring in, change, and store. Exam questions often test whether a candidate understands where errors can occur, such as during transformation when types are coerced, or during load when keys no longer match.
Metadata is data about data, such as who created a dataset, when it was created, what fields mean, and what units or time zones apply. Lineage is the recorded path of where data came from and how it changed, including sources, filters, transformations, and destinations, so results can be reproduced and defended. A source of truth is the place an organization agrees is authoritative for a specific piece of information, such as the system that defines customer status or the table that defines revenue logic. In practice, metadata helps people understand a dataset. Lineage helps people trust and reproduce a result. And source of truth helps people avoid argument over which numbers count. For example, a sales total can be debated endlessly if two teams pull from different systems, but it becomes stable when both use the same defined source of truth and can show lineage back to it. Exam stems that mention conflicting reports or audit questions often point toward these concepts because trust depends on knowing meaning and provenance.
Completeness describes whether expected data is present, such as whether every required record exists or whether important fields are filled in at an acceptable rate. Accuracy describes whether the data matches reality, such as whether an address is correct or whether a timestamp reflects the true event time. Validity describes whether the data follows allowed rules and formats, such as dates that are real dates, numeric ranges that make sense, and codes that match known sets. These quality terms are related but not identical, because a dataset can be complete but inaccurate, or accurate in some fields but invalid in others because of format issues. The exam often tests this by describing a dataset that looks large and complete but contains errors that make it unusable for decisions, or by describing a dataset with missing fields that changes the interpretation of trends. A strong answer uses the right quality term for the right problem because the fix and the risk depend on which quality dimension is failing. An outlier is a value that sits far away from the rest of the values, like a purchase amount that is much larger than typical, which might represent fraud, error, or a rare real event. A distribution is the overall shape of values, such as whether most values cluster around a middle, whether the data is skewed, or whether there are multiple clusters. Variance is a measure of how spread out the values are, meaning whether values are tightly packed or widely scattered around the average. These terms matter because they describe what the data looks like, and what the data looks like determines what summaries are meaningful and what modeling assumptions are safe. In everyday words, outliers are the oddballs, distribution is the pattern of where values tend to land, and variance is how much values wiggle around the center. Exam stems may hint at skew, unusual spikes, or unstable results, and these clues often point toward distribution thinking rather than a specific named technique. A metric is a measured number used to describe something, such as total sales, number of active users, average response time, or count of incidents. A key performance indicator, often spoken as KPI, is a metric chosen because it is tied to a goal and is used to track progress, not because it is the only number available. A baseline is a reference point used to compare change, such as last month's average, last quarter's total, or a pre-change measurement used to assess whether an intervention improved outcomes. These terms can become business fluff, so the safest approach is to keep them concrete, meaning a metric is a number. A KPI is the number people agree matters for a goal, and a baseline is the comparison point. Exam questions often test whether a candidate understands that metrics require definitions and time windows, and that baselines must be comparable in scope. Clear definitions prevent a KPI from being misused as a vague label for any chart. A dashboard is a collection of metrics and visuals designed to provide a quick view of status, often with interactive filters and drill-down behavior. A report is a prepared output that presents information in a more fixed format, often for a specific audience and time period, and it may be scheduled or archived. A filter is a way to limit what is shown based on conditions, such as a date range, region, or category, which changes the subset of data being summarized. Refresh describes how and when the dashboard or report updates its data, such as hourly, daily, or on demand. And refresh behavior affects whether the view reflects current reality or a snapshot. These terms matter because many reporting errors are not calculation mistakes, but mismatch mistakes, where the user thinks they are looking at one time window or population while the tool is showing another. Exam stems sometimes describe stakeholder confusion, and the root cause is often filters or refresh schedules that were not understood or documented. Access control is the set of rules that determines who can see or change data, often tied to roles, groups, or specific permissions. Encryption is the method of turning data into unreadable form without a key, protecting it during storage or transit so unauthorized parties cannot interpret it. Masking is the method of hiding part of a sensitive value, such as showing only the last digits of an account number, so data can be used for certain tasks without exposing full details. Anonymization is the process of removing or changing identifying information so a person cannot reasonably be re-identified, which is stronger than masking and often harder to guarantee in practice. These terms matter in data roles because data handling is a security decision, and exam stems often include sensitive information where the correct answer depends on choosing the right control. A steady way to recall them is that access control limits who can touch data, encryption protects data if it is intercepted, masking hides details while keeping format, and anonymization aims to break the link to a person. Extract, transform, load, ETL, and extract, load, transform, ELT, are commonly confused, but the difference is the order and where transformation occurs. ETL means data is extracted from sources, transformed before it is loaded, and then loaded into the target, which emphasizes cleaning and shaping earlier in the pipeline. ELT means data is extracted, loaded into the target in a more raw form, and then transformed inside the target system, which often fits environments where the destination has strong compute and management capabilities. The exam usually expects the candidate to connect ELT to situations where raw landing is prioritized and transformation can happen later with scalable resources, while ETL fits situations where data must be standardized before it can enter a curated system of record. The key is not to treat either as universally better, but to match the sequence to constraints like ingestion speed, governance, and where transformations are most maintainable. Saying the words as actions, meaning pull, then clean, then store, versus pull, then store, then clean, keeps the difference stable. A spoken drill routine for the glossary works best when it is short and predictable, because predictability supports recall without adding mental overhead. One effective routine is to choose a small set of terms, speak each definition in one sentence, and then add a second sentence that gives a simple use case, such as how the term appears in a reporting or pipeline scenario. Another effective element is to rephrase the definition without the term, because that proves understanding rather than memorization of a label. Short pauses before speaking the definition help force retrieval, which strengthens memory more than listening passively. The routine should also include one or two confusing pairs, such as ETL versus ELT or table versus view, because distinguishing similar terms is where exam mistakes often happen. When this drill is repeated across days with spaced intervals, the glossary becomes automatic and explanations become smooth. To conclude, the glossary is valuable because it creates clean definitions that can be spoken quickly and used reliably in exam scenarios and workplace conversations. Dataset, record, field, and value establish the basic structure language. Language, primary key, and foreign key explain relationships. And schema, table, view, and index describe how structured data is organized and accessed. Pipeline, ingestion, transformation, and load explain how data moves, while metadata, lineage, and source of truth explain how trust and reproducibility are maintained. Quality terms, distribution terms, reporting terms, and security terms fill in the rest of the high-yield vocabulary. And ETL versus ELT is a key confusing pair that becomes easy once the order is tied to where transformation happens. 10 terms to rehearse this week should be chosen from the ones that still cause hesitation, and they should be spoken daily with one sentence of meaning and one sentence of use. Pick those 10, say them once aloud, and the recall will tighten quickly because spoken clarity is the strongest proof of understanding. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.